What? Huh? Oh! Welcome everybody. Welcome everybody to Play Well Live. It's Ben and we are here in my garage today. And something else I love to do other than build and teach with Lego is work with wood. And my grandfather actually used to build cabinets. He was a cabinet maker. And so I have a lot of his old tools from years and years ago. And it's one of my favorite things to do other than build with Lego. So this story today begins with my son who recently had his birthday. He recently turned 5 years old. And what did he ask me for? He said, "Daddy, I want a jigsaw. I want my own jigsaw." Now, those of you who don't know what a jigsaw is, this is a jigsaw. And you can see it has a blade that sticks out here. And when I turn it on, you can see that blade, which is very sharp, goes up and down very fast, and it can cut pieces of wood. Not very appropriate for a boy that is turning 5, but he really wanted one. So my solution was to make a Lego version of one. I knew I couldn't fool him with something that didn't actually cut. So I wanted to see if I could rig up a Lego jigsaw that could actually cut something. My goal was maybe see if it could cut paper, or if I was lucky, maybe cut cardboard. So what I did with is I needed some kind of a blade. So to start with, I used a hacksaw blade, which the teeth on a hacksaw blade, they're much finer and closer together than on a real Lego jigsaw. So it's much safer. It's still, you gotta be careful, but it's much safer. If I rub my hand on this, it won't hurt my hand. Whereas on a real jigsaw, these teeth are meant to cut wood and they're very, very sharp. So the question was, how do I get this into a Lego jigsaw and make it work? So what I ended up doing was using some big cutters, and I took one of the jigsaw blade or the hacksaw blades and I cut it out, and I actually, kind of like we did for building the tree house, drilled a few holes that fit Lego axles, and I used kind of a half blade in my Lego jigsaw. Now, how does this work? How does this jigsaw actually work? It's very simple. I'm going to show you a mechanism that you can build at home with only 10 pieces that really does the same motion as this jigsaw. Now, first of all, here's the main problem with our engineering on our jigsaw. We need a saw blade that goes back and forth. We call that motion reciprocating. Reciprocating is something that goes back and forth in a line like this. But the problem is motors turn in a circle. So we have motors that turn around like this, but we need to result in something that goes back and forth so we can cut. So here is the trick. The first element of this, and then we're going to, and stick around because we're going to actually try to cut with this thing, and I'll show you a little bit how this works. But something you can build at home first starts with, let's make something that can actually slide back and forth. I'm just going to use this smooth Technic beam. Now, the first thing we need to do is make sure that it has something to constrain it. So when it goes back and forth, like a sled, so it can go back and forth without falling all over the place. So the easiest way to do that, I'm taking a 4x4 plate, sticking a brick on it, a 2x4 brick, and you can see this can slide right in between like this. And then what I'm going to do is I'm going to make kind of like a letter P here, and I'm going to put a long studded beam on one end of that square. So now I've left a little hole, a little slot, that if I put this smooth beam and I put it in like this, it can slide back and forth in that slot. Now it can still pop out. So then the other thing that I'm going to need to do, if I can find it, is sandwich this like this. So now I've made a little track, so that this now can go back and forth, and it's constrained, which means it has nowhere to go but back and forth. And if you remember that kind of motion, it's called reciprocating motion. Now for the next problem, how can we make this go back and forth if we have a motor that's spinning around and around and around? So again, it's not that hard. It's similar to what Mike Spee did with his inchworm, where he took a wheel or a gear, any kind of wheel, and he stuck some kind of a pin on the outside of the center of that wheel. We call that motion eccentric motion. If you've ever heard the word eccentric, it means kind of weird. Like, oh, that's an eccentric looking bug. And eccentric also can mean not in the middle, not in the center. So when it's weird, it's like, oh, that's not normal. So eccentric is something outside of the middle. Now, when we have something like this is what we call a crank. You can see, you might have seen a crank where if you hold this with your finger and I go like this, I can crank something around. If you hold a crank, which is not in the middle of a wheel, you can turn something. Now, the last step is literally to attach this crank to this beam. And we call this a throw arm. So basically, if I have two pins like this, one pin on my, which is basically going to be my saw blade, and one on my wheel, and I connect them with a connecting rod or a connecting arm like this, now when I turn this wheel, the crank turns and pushes my element back and forth. And that's it. So this is really 10 pieces, and this is the same exact mechanism that I use for this big crazy jigsaw, and it's the same mechanism that you would find in a real jigsaw. Same kind of thing that you would find. Now, obviously, if I have a bigger wheel, and I put maybe a larger wheel on here, so that pin or that crank is further from the center, now I have what's called, it's a bigger throw, which means it throws that beam. It has a bigger movement back and forth. And so you can see the bigger the wheel, the more that crank pushes that beam back and forth. Now, with this crazy thing, I had a lot of failures. This is actually my second draft. I made one, and I made it so that my blade actually went right through the middle of this and went back and forth, and this was like this, and it ended up, hi Stacy, thanks for hopping on again, one of our most devoted fans, I appreciate it. This went back and forth, but it eventually started catching on the Lego itself, and if you could see, it actually started cutting a little bit of the Lego there. So just having this be kind of the sliding element wasn't good, because I don't want my sliding element to have teeth. Failures? Are you kidding me? We have failures all the time. You're right, Stacy. I have Lego failure after Lego failure. If I'm going to build anything that actually works, you've got to fail over and over and over and over again. And you can't get upset. You have to be patient. And every time you fail, you got to learn a little something. And that's what I did. So I didn't want to cut my Lego in half. So what I did is I made a little sled which did the sliding that held my blade. Let me see if I can get it out. Here we go. I made this. So instead of having my blade go back and forth, I attached my blade into this little sled, and the sled is what fit inside this little track right here and did the sliding back and forth. And so that prevented any unnecessary or any unwanted cutting. So I didn't have any busted up Lego. So that is basically the engineering. We've got a crank that pushes a connecting rod or a throw arm, and that pushes something going back and forth, which is reciprocating motion. Now, should we see this thing cut? Let's see if it can cut. Now, the first thing I'm gonna do is I'm gonna start easy. I'm gonna start with paper. I gotta at least have one win on here, because this is live and I don't want this to go too wrong, okay? So we've got a little paper bag here. Maybe I'll move you down below so you can get a better view of the cutting. Are we okay down here? Let me see. I hope everyone can hear me. All right. It says I don't have great connection, but we're gonna try this out and see. All right, you ready? Here we go. Okay, Lego Jigsaw, test 1. All right, down there, but hopefully you were able to see that cut pretty well. Now, with any kind of saw, it's very important that, you don't push the saw to do the work. So you let the teeth just go back and forth, do the work. Now what we're gonna do is we're gonna move up to cardboard and see if that works, okay? I'm sorry if this is dropping off a little bit because I know my connect. Try this again with cardboard. All right, so I've got my here from my Lego set, and we're gonna see if this works. All right, it definitely went slower, but we had a successful cut. Let me turn it around so you can see. It cuts cardboard. And now we're gonna do one last test. And I know, I'm very sorry, I feel like this connection is not working great when I'm laying my phone on the ground and when we're cutting from the garage. But you can always watch this video later if this is not working great. So sorry about the connection problems. Last test, we're gonna try a little bit of wood. Okay, this is some LEGO's test number 3, trying to cut a little piece of LEGO Jigsaw. That way, that would be good. We have an itty bitty baby cut. It works. You'd be there all day if you wanted to cut through a piece of wood, but it does work. So, hope you enjoyed that little run through of our LEGO Jigsaw and learned a little bit about how you might make a similar mechanism at home. Thank you for hanging out in my garage in my wood shop this morning. And I'm very sorry if there was any connection difficulties. Maybe you can go back and check out the video after it saves back to Facebook. So I hope everybody is safe and happy and continue to build. And if you make anything cool, I continue to check out our little hashtag play well at home. So please check that out. And I look forward to seeing you all next time. Take care.